Greetings, and thank you to the BPHO team for taking the time to watch our presentation. This is Aayush, Joshi, and Sohaib Alam's entry for BPHO 2024. We've created an interactive model using C++ as a desktop application, encompassing all the tasks for Projectiles 2024. Let us begin. The backbone of our application uses SFML as the graphics library, and to create interactivity, we use IMGUI. Every task has its settings exposed to the user using sliders to control inputs for our simulation. This allows for better visualization of the effects of changing the initial conditions. Task 2 is defined as a function called Cartesian projectile, as it forms the basis for much of the latter tasks. This was expanded to Task 3, allowing users to pick coordinates on screen using a mouse. Tasks 4 and 5 are equally as trivial to implement. Task 6 includes a text section where the distance traveled is updated as the initial inputs are changed. Task 7 has a toggle button to toggle between the range time graph and the XY graph at different angles. We've extended this by adding the launch height too. Task 8 involves using the Valet method to calculate the next position of the projectile. Task 9 was solved using the Cartesian projectile function and using Valet for the air resistance plots. We stored the acceleration, velocities, and position vectors for each time step to simplify plots of each graph.
The extension, which was to draw a projectile on the Earth, still used SFML's 2D API, and therefore we needed to project a 3D object onto a 2D screen. We needed to use the GLM library, as this process involved the heavy use of vector matrix multiplication. We started off with an octahedron and subdivided its basic equilateral triangles into smaller triangles, and then normalized them to get a sphere with the desired radius. Each vertex was then multiplied by an MVP matrix unique to the sphere, and once in screen space, these vertices were then rendered as a 2D triangle. Then, to get our starting location for our projectile, we converted latitude and longitude coordinates into Cartesian coordinates, and with the given inputs we were able to use the Valet method to give us the desired arc with respect to the changing gravity and rotation of the Earth. For more details, I highly recommend reading the write-up, as this is a very superficial overview of the complicated process.